Question 12, we're getting to the end, so we're going to expect some slightly more complicated algebra in this, and you're certainly going to get that in part A here. We're being asked where point A is, where these two curves meet. So let's just write these two things equal to each other. We want this to equal this. You're panicking, but don't. Just let's drag everything over to one side. We always do that sort of thing with equations. Make them equal 0. And the moment of inspiration here is to notice that this is a quadratic. It's a quadratic in x squared. So if I let some other letter equal x squared, equal square root of x, then the square root of x could be a here, and this is a squared. So there's a quadratic to solve. We can solve that on our calculator. Solving that on our calculator gives me, here's the calculator, 5, 2 and minus 16, gives me that one answer for A is 8/5, and the other answer for A is minus 2. Now since A is the square root of x, then that means x is 64 over 25, or x is 4, and we've square rooted it and taken the negative part of it. What I would do now is actually check this works, and so if I stick a 4 in here, I get 12 take away 2 lots of root x, that's 12 take away 4, that makes 8. And if you put a 4 in there, 8 times 4 is 16. It is 32, take away 6. My point is it doesn't work. That one there does not actually work. This is the only answer. And we figured that by throwing it back in and working it out. Part B, only 3 marks for this, but almost as hard here. We've got some obvious bits. Look, this one here was that square root curve, wasn't it? So we know that y must be lower than that, and it's a solid curve, so less than or equal to this bit here. We've also got the dotted line here, and we want to be above that, so y is greater than the 8x minus 16. The only thing we need to find now is this line here, because x is going to be greater than that value. And that is when is this equal to 0. So I've got 3x minus 2 root x. We want that, look, it's here is 0, so equals 0. Could do another quadratic here, but actually what I'm going to do is I'm going to take out a factor of root x here. And I've got 3 root x minus 2 equals 0. That's telling me that that curve is equal to 0 either at 0, well that's there, or at 3 root x minus 2 equals 0. So add the 2, divide by 3, so x is 4/9. So the bit that we want is everything to positive of that. So sorry, is this bit is positive than that. So it's x is greater than 4/9. And it's solid, so greater than or equal to. If you didn't like that line there, just shift solve that one there. Or actually, you could do what we did earlier. You could let a equal the square root of x, and then you've got 3a squared minus 2a equals 0, and you could work through it like that as well.